The Effect of Temperature on Decomposition by Tiara Corbin. Decomposition is a process where dead plants, animals, and waste materials are broken down into simpler substances. This happens because microorganisms like bacteria and fungi feed on the materials and help return nutrients back into the soil. Decomposition is important because it reduces waste and helps keep ecosystems balanced. Different conditions, such as temperature, moisture, and the type of material, can affect how fast decomposition happens. In my experiment, decomposition was studied by observing how different temperatures change the rate at which common trash materials break down over time. How does temperature affect the rate of decomposition in soil? My hypothesis is that freezing temperatures will slow down microbial growth in the soil. Prediction is that the overall percentage of decomposition of the garbage kept in the freezer will be lower than the overall percentage of garbage kept at room temperature. My independent variable will be the temperature that the trash is kept at, which is freezing versus room temperature. My dependent variable will be the amount of decomposition. My control bin will be the room temperature bin, and my constants will be the amount of water, the amount of trash, the amount of soil, and the number of holes punched in the bins for airflow. Materials used. Each bin contained the same types of materials. For plastic, I used water bottle pieces. For paper, I used notebook paper and sticky notes. For processed food, I used white bread, Doritos. For fresh food, I used lemon. For yard waste, I used leaves. For metal, I used metal hooks. For wood, I used sticks. For biodegradable material, I used Q-tips. Alright, so I created a chart on quantitative observations. I recorded the percentage of mass lost for each material in both the room temperature bin and the freezing temperature bin. Material in the bin that was kept in room temperature decomposed much faster compared to the bin kept in the freezer, which preserved material pretty well. The paper, sticky note, lemon, leaf, white bread, and Dorito lost 100% of its mass in the room temperature bin, but in the freezer temperature bin, only the leaf lost 100% of its mass. There were two materials that decomposed faster in the freezer bin than in the room temperature bin, which was the metal hook that lost 9.8% of its mass, and the Q-tip, which lost 10.5% of its mass. I do feel that because the metal hook was kept in cold temperatures, it caused wear and tear. And with the Q-tip that was kept in the room temperature bin, it absorbed water more easily, which I think helped maintain its weight. I also created a chart for qualitative observations. I found that the freezer bin didn't really experience many qualitative differences compared to the room temperature bin. The room temperature bin experienced a lot of apparent changes, especially with food, but I did find that materials like plastic, metal, the Q-tip, and the Q-tip all looked similar to themselves before and after in both the room temp and freezer temp bin. So if we look at the Q-tip and like the sticky note, they had changed colors, and then with the food, they had all decomposed fully in the room temperature bin. And then a lot of the freezer temp bin, I would say, preserved pretty well. There were little changes, but they weren't very major, especially compared to the room temperature bin. Here are some photo comparisons. On the left side, we have comparison of white bread in both room temp, which is on the left, and then freezer temp, which is on the right. This is just from week 3. As you see, the room temperature bread was very moldy. This was right before it had decomposed fully. And then on the right side, we have lemons from room temperature bin and freezer temperature bin from week 2. I remember the lemon being very, very brittle and delicate. I could hardly pick it up just to weigh it. It was just crumbling within my hands. I mean, I couldn't even get the dirt off to see what it would look like. It decomposed fully by the midst of like week 3. And then we look at the freezer temp lemon, which is preserved pretty well. I mean, it has dirt and stuff on it, but overall the shape and the original form of the lemon is the same. And then for these comparison photos, I was taking note of the discoloration. So these top 2 photos are both from room temperature bins, but they're from different weeks. The first one is week 4, which we see is a bright orange color. And then, week 1, I'm sorry. And then the one next to it is from week 4, which becomes a yellowish, whitish color. It's also more thinner, and it was soggy feeling. And then on the bottom, these are both from freezer temps. We can see that in both week 1 and week 4, they haven't really changed color. I think they personally look the same. The lighting is a bit different, but I don't see really many apparent changes. It's a little wrinkly, but that's about it. So overall, I would say that the results support my hypothesis. Freezing temperatures slowed down microbial activity, which causes decomposition to happen more slowly compared to room temperature. For example, food items like lemon and bread decompose much more in the room temperature bin, while the same item showed little to no change in the freezer bin. Possible sources of error in my experiment would be probably temperature fluctuations in my freezer. It is being used, so it's open and closed often, and I don't think that it's always consistently at the same exact temperature. That's why I kind of just labeled it as freezing temperatures, because I didn't want to say it was a specific temperature. I would also say that the scale wasn't always accurate. I don't think it was. I'm not sure. And then I think it's pretty hard for me to be very exact about the percentage of decomposition, but this is just based off of scaling. So an experiment proposal after doing mine would be, how would decomposition change if the bins were kept at different warm temperatures instead of freezing temperatures?